Hello, welcome to this lesson. In this video, we are going to solve this question I have on the screen. The question says determine the magnitude of forces C and T, which, along with the other three forces shown, act to keep the charge joint in equilibrium. So let's look at how you are going to solve this question. So this system here is a 2D system where the forces are concurrent because their line of action meet at a common point here. Okay, so for this reason, we know that we are going to need just the two equilibrium equations, which is for the forces. So let's look at how you are going to do this. So you have the solution, and then you're going to need just the two force equations, which will be the sum of the forces in the x-axis direction to be 0, and then the sum of the forces in the y-axis direction to be equal to 0. So for this reason, you have to find the components of the forces that are at an angle. So considering force T, it is at an angle of 40 degrees to the horizontal. Okay, so it is going to have an x and y component. So taking cosine of the 40 degrees, okay, will give us the adjacent side, which will be the x component, so that will be tx over the hypotenuse t. So I'm going to have the x component tx to be equal to t cosine of 40 degrees, and then I'm going to have ty to be equal to t sine of 40 degrees. Okay, so now let's do the same for the force C. So for the force C also, it will have components, right? Because it makes an angle of 20 degrees with the vertical axis, right? So for this one also, this will be the x component, and then you're going to have this to be the y component, right? So let's look at that. So taking sine of the 20 degrees will be equal to the opposite side, right? Which will now be the s part, that will be cx, right? Over the hypotenuse, that will be what c. So you're going to have cx to be equal to c sine of 20 degrees, right? And then you're going to have cy to be equal to okay, cosine of what 20 degrees, but because it is the y component is acting the negative y-axis direction, you will have to negate this, so this becomes negative. So now we know the components of the force that were at an angle, and then we know the other forces. Okay, so we can apply the two equilibrium equations and then find the unknown values. Okay, so applying the equilibrium equations, for the first one, we have the sum of the forces in the x-axis direction to be equal to 0. Okay, so for that one, you're going to have t cosine of 40 degrees, okay, plus c sine of 20 degrees, okay, plus 8 kilonewton, right, minus 16 kilonewton. Then this should be equal to 0. And then for the sum of the forces in the y-axis direction, that one also you are going to have t sine of 40 degrees, right? And then minus cosine of c cosine of 20 degrees, okay? And then minus 3 kilonewton, and then this should be equal to what? 0. Okay, so this should be the first equation. This should be the second equation. So from the second equation, I'll make t the subject. So you're going to have t sine of 40 degrees. Okay, then that will be equal to c cosine of 20 degrees plus 3, right? So I'll divide both sides by sine of 40 degrees. So divide by sine of 40 degrees. Divide by sine of 40 degrees. Okay, so let's simplify and see what you are going to get. So this will cancel out this, and then you're going to get t to be equal to c cosine of 20, okay, divided by sine of 40, and then that'll give us a value of 1.462c, okay, plus 3 divided by sine of 40, that will be plus 4.667. Okay, this is what you have. So let's take note of this equation here. Okay, so now let's go back to the first equation. We have t cosine of 40 degrees plus c, so plus c sine of 20 degrees. Okay, and then we have plus 8 minus 16, so that will give us minus 8 equals what? 0, right? So we know what t is, so we can do the substitution. So we are going to have 1.462c plus 4.667. Okay, all this multiplying cosine of 40 degrees plus c sine of 20 degrees. Okay, let me just send the 8 here because 8. So let's do the multiplication, then expand the bracket. So I'm going to have 1.462c multiplying cosine of 40. That will give us a value of 1.12c. Okay, and then plus 4.667 times cosine of 40 degrees. That will give us a value of 3.575. Okay, plus c sine of 20 degrees. This should be equal to 8, right? So let's take this value here to the right hand side. So I'm going to have 1.12c plus c sine of 20. Let's see what sine of 20 is. Sine of 20 degrees will give us 0.342. So plus 0.342c. Okay, this should be equal to 8 minus 3.575. So let's do the further simplification. We're going to have 1.12c plus 0.342c. That will give us a value of 1.462c. This should be equal to 8 minus 3.575. That will give us a value of 4.425. So let's divide both sides. Okay, let's divide both sides by 1.462. So we divide by 1.462, divide by 1.462. Okay, so this will cancel out this. You're going to have c to be equal to 4.425 divided by 1.462. This will give us a value of 3.027, right, which are around to 3.03 kilonewton, right? And then you are going to substitute this into what you have here to get t, right? So let's look at that. So you're going to have t to be equal to 1.462 multiplying c, which will be 3.03, okay, plus 4.667. So let's see what you're going to get. You're going to have 1.462 multiplying 3.03, okay, plus 4.667. Okay, this is what you're going to have. Then when we simplify this, you're going to have this to be equal to 9.097, right? So this will give us t to be equal to 9.1 kilonewton. So that will be the value of t